Hello and welcome back to this tutorial series on Introduction to MATLAB. Till now I have discussed many concepts of the MATLAB in these 8 tutorials, and you can access these tutorials by simply going to the playlist Introduction to MATLAB. In this tutorial I am going to discuss about some of the practice problems, and we will try to implement all those concepts we have learned till now. Let's get started. So these are some of the practice problems that I am going to discuss in this tutorial, and we will try to implement all those skills we have learned till now. So first problem is explore the graphic user interface of the MATLAB, and we will try to complete these two tasks. First one is the change the folder location, and the second one is the change the font size in the command window. Let's move to the MATLAB. So this is graphic user interface, and at the top we have this in the blue color. This is called as menu bar, and which contains three tabs: home, plots, and apps. So what we have to do is, so this is the search bar where the folder location are indicated, and we are going to change this folder location. So right now I am in the documents MATLAB folder, and I want to change this folder location. Let's suppose I want to move to the documents. So you can change this folder location by using these three different folder icons. So first one says up one label, and this one is the access MATLAB drive, which basically you can use to store the MATLAB files on the MATLAB drive. And the third one is the browse for folder when we want to move to some specific location. So let's use this first option over here, which says up one label. So I will press this folder icon, so it will change the folder location from MATLAB to this documents. Next we can use this folder location icon which says browse for folder. So if I click on this menu saying select a new folder will pop up, and we will try to change the folder location from here. So you can simply go whatever location you want. I want to move back to the MATLAB folder, so I will double click on it, and now if you see in the folder name over here, it's indicate in which folder we are going to move now. So it says documents MATLAB. So if I click on open, so my folder location will now change back to the MATLAB. Next task we have to do is we have to change the font size. If I write something in the command window and these words have some font size, so to know the font size of this, we will move to the home tab, and we will click on this environment section, and we will choose preferences. When the preferences are clicked, this window will open which says preferences, and to change the font size we will move down, and over here it says fonts. Now in the MATLAB fonts preference, at this location you can see the default font size that we are seeing right now is 10. Now to change the font size, we will click on this arrow, and you can choose whatever font size you want. So let's click on 18, and if you see over here it says sample, so that means if you choose this font size of 18, so this font size of 18 will look something like this. So let's just apply it and click OK. So you will see now the font size is changed from 10 to 18. Let's see the next problem. So the next problem is the calculate, and we have given this expression. So let's split this or try to understand this operation given here. So this portion is numerator and this is the denominator, and then we have to take the square root. So we basically have two steps. First we calculate this expression, and then we will take this square root. So to complete this task, so we have to write in the numerator 5 into 76 plus 250 minus 305 divided by 650 into 0.1. So let's move to the MATLAB, and I will start writing this expression into the command window. So this expression contains 5 into 76 plus 250 minus 305 divided by 650 into 0.1. So this is my numerator part. Now if I have to divide it by 10, so I will use this division symbol, and then I will press 10. If I press an enter key, this result I will get, but this is not an accurate result. What happened actually is, let's see it by step. So if I write 5 into 76 plus 250, so this expression I will get 630. And if I calculate 305 divided by 650 into 0.1, I will get this expression over here, 0.0469. Now you know that this calculation is stored in this default variable which is answer, and if I divide answer with the 10, I will get this 0.0047. This result 5 into 76 plus 250 was 630, and this result or calculation of this one was 0.0047. So this 10 basically divide only this part of the calculation, not the whole part. If you see in this problem here, this denominator 10 is actually dividing this whole term, and when doing in calculation in the MATLAB, it is only dividing this term. To divide the whole term, what we have to do is we have to enclose the numerator into these brackets. So these small brackets we will use to enclose all the expression which is available in the numerator, and then we will use the denominator to divide it. So let's start writing 5 into 76 plus 250 minus 305 divided by 650 into 0.1. So this covers my numerator part. Now I will divide it by 10, so which is basically in the denominator, but denominator have only single value, so I do not have to use any bracket. So I will press an enter key. I will get this result. So this is our accurate result, and the result that we got here is not the correct result. So this is my correct result. Now we have to take the square root of it. So let's use help elfen, which is basically give the mathematical functions that is available in the MATLAB, and let's find out the square root option here. So this is my square root, and which basically use this sqrt command. So to take the square root of the calculation that we have done earlier, so I will call this square root function, and to call it we have to use this index bracket now, and then I will supply the value that is answer, and if I press an enter key, it will give me 7.9370. So we did in the multiple steps. We can do the same operation in the single line. So I will first write square root, then I will use this bracket, index bracket, to call the function square root, and then I will use another bracket to supply the numerator part into it. So I will write 5 into 76 plus 250 minus 305 divided by 650 into 0.1, right? So over here, so 305 divided by 650, this will be evaluated along with this multiplication of 0.1, and then I will divide it by 10, and now I will press an enter key. So the same result I get in the single line. So use of these brackets are actually helpful when we want to evaluate complete expression into a single lines. Okay, next we will move to the next problem, which says operate some trigonometric function on result of 2. So whatever result we get using by calculating this result in the second, we have to use this result to find out some trigonometric, to implement some trigonometric function on that result. So let's move to the command window, and if you look in the help elementary functions, these are some trigonometric functions that are available here. So let's just use some tangent or cotangent, whatever you want. So I am using tangent here, so I will use tan. So it will give me the tangent of some angle in radian. Now I will supply the value. So value is stored in the answer variable, so I will supply that variable, and if I press an enter key, this will give me the tangent of this 7.9370 radian value. So this is minus 12.0239, and till now we have not supplied any variable. If you are familiar with the tutorial, I have discussed how to create a variable. So till now it is storing the value in the default variable, so it is again and again replacing by new value. So if you see in the workspace, we have only one variable, and the value that is stored in it is minus 12.0239. Next one is the fourth problem. So till now we have stored all the answer in the default variable answer, which is short form written as ans. Now we will create a variable of our own, and we will store a value in it. Then using that variable we will evaluate this expression, which says create a variable y, and then store this value of x square plus 5x plus 6 divided by x cube plus under root 5x minus 4. So let's first create a variable x and store a value in it. Let's suppose store a value of 8 in it. Next thing we have to do is we have to evaluate this expression, and this expression is stored in this variable y. So to create a variable y, we will write y, then we will use the assign operator, which is equal to sign. Now we have to evaluate numerator and denominator. So for that purpose we use this bracket. Then I will supply x square. So to write x square, we will write x to this operator, x raised to the power, and then I will write 2, that means x square. Now I will use 5x, that means 5 times x. So I will use 5 into x, then I will press plus, and then I will supply 6. So this is my numerator part. Okay, so if you see here, so this is x square plus 5x plus 6. So this is my numerator part. Now I have to supply this denominator part. This says x cube plus root 5x. So I will press this division symbol, then I will use again brackets, because now we have to supply multiple values here. in the denominator as well, so I will use this bracket. Then I will write x. For cube we have to use this raised to the power symbol, which you can simply access by using shift plus 6 on the keyboard. And then I will write root of 5x. So first we take square root, so I will write sqrt, then I will use this bracket, then I will supply 5 into x, and then I will supply minus 4. If I press an enter key, this is my result. This is 0.2139. okay, so this is how you can operate on some variable, and with the help of these bracket we can easily calculate the result within single line. Next we have the fifth problem, which says find these operations. So first one says cos x square, second one is cos square x, another one is the log base 10 x power 5, and the last one is x factorial. This symbol over here represent we have to calculate factorial. So let's move to the MATLAB, and to find out the cos x square, so we have to call the function cos, and then we have to use this index bracket to call the function, and then I will supply x square in it. So first we will evaluate, so what MATLAB will actually do, it will evaluate x square and then we'll take the cos of it. If I press an enter key, so cos x square means 8, so x is basically 8, so 8 square means 64, so that 64 will be taken as in a radian, and this will evaluate the cos 64 radian value, which is 0.3919. Next we have to calculate cos square x, so which basically means first we calculate cos x and then we will take the square of it. Okay, so this is how we do in the MATLAB. So first we take cos x, we evaluate this operation, and then we have to take the square of it. So for raise power we have to use this symbol or this operator, and then we will write 2 in this. So this means cos x square. If I press an enter key, so this will give me 0.0212. Next one we have to use the log base 10. So if I go here in the exponential, you see for the base 10 logarithmic we have to use this function called as log base 10. So log 10 we have to use. Let's call this function log 10. Then I will use this index bracket to call the function, then I will supply x power 5. So we use this operator over here to raise power, and then I will supply 5. This give me 4.5154. Next we have to take factorial. So if you remember in mathematics, to find out the factorial we do the operation like this. So 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, so if I press an enter key, so this is my 8 factorial value, which is 40320. You can also find out factorial using some function known as factorial that is available in the MATLAB. So I will use factorial and then I will supply this x. You will see we will get same result which we evaluated using this. So this is the shortest way to find out the factorial of any number. Let's suppose I have x is equal to 150, and then if I start writing using this way, it's gonna take a lot of time. So we will just simply call this function known as factorial, and then I will supply that number into it. Next one we have this sixth problem, which says create a vector b which contain first 5 odd numbers. So the first 5 odd numbers are 1, 3, 5, 7, and fifth one is the 9. So this is the first 5 odd numbers. So we have to store this into a vector. Now let's create a vector b, whatever name you want to give it, which contains first 5 odd numbers. So I will write this b, then I will press this equal to sign, which is a sign operator, and then I will start creating vector. So I enclose them into these square brackets. So we have first 5 odd numbers, 1, 3, 5, 7, and 9. Now because I am using space in between, so it's going to be a row vector. You can create also a column vector. For that you have to separate these elements by using semicolon, but I am creating a row vector, so I will separate them using space, or I can use a comma as well. So you can use anything you want. So if I press an enter key, I will get this b, which is a row vector 1, 3, 5, 7, 9. You can try to create the same vector in the column way. So you can create a column vector using these first 5 natural number. You can try that. Next we have the seventh problem, which says create a vector t which contain element between 0 to 20 with step size 0.1, and then we have to evaluate this expression 9 sin t plus 6 e to the power 5t. So let's move to the MATLAB. Let's create a vector t, or you can give it whatever name you want. So I am using small letters or small alphabets for creating a vector. Now I will use this square bracket if I want to give each and individual number in it, but I don't want to use this way to create a vector. I have some another way to create the same vector, which says we have to create a vector between two elements 0 and 20 and with the step size of 0.1. So to do that, we have to use something called colon operator, because we have given the step size. So I will use 0, which is my starting point, then I will use this colon operator, and then I will use step size 0.1, and then I will use again colon operator, and then I will supply the last point, which is 20. If I press an enter key, a vector will be created which contains 201 columns. So you can see here as well, which says column 201. So last element is 20. Also you can see in the workspace this variable t is created which contains 1 rows 201. That means it contains 1 row and 201 columns. You can also check the size of this vector. So if I use this size command, which is basically used to know the rows and columns in the vector or matrix, so if I press an enter key, it will give me a rows number which contains 1 row and 201 columns. So by default, using colon operator, we create a row vector. Next we have to evaluate that. So I have to use the sine function, and this function over here is exponential function. So I will use exponential and sine function to evaluate this expression, which is 9 sine t plus 6 e to the power 5t. Let's move to the MATLAB. Let's store that value in some variable c, and then I will supply 9 into sine. I'm calling the sine function, then I will supply this vector t. Then we have to use 6 e power 5t. So that means 6 times. So for multiplication we have to use the star symbol. Then I will use exponentials. So in the MATLAB, for exponential we have this command called as exp, and then I will write 5t, 5 into t. Okay, because we are calling the function, so we have to use this index bracket. So if I press an enter key, a vector c is created, which is basically 9 sine t plus 6 times e to the power 5t. Some of you might wonder why not we are using e raised power. Let's try out that. So 9 times sine t, so I will use this, and plus 5 or 6 times exponential. If I use this raised power, then supply it 5 into t. If I press an enter key, MATLAB will throw an error, because this is not applicable here, because we have to call the function, and to call the function we have to use index bracket along with it. So we cannot use this e exponential to the raised power. Okay, so because this built-in function is written in such a way that you have to call it in this way. So I will use exp, then I will use this index bracket, and then I will supply the value that is in the power. So we have exp power 5t, so that 5t will be supplied in between these brackets. Next one, we have this 8th problem, which says create a vector which contain 1 to 365 days of a year. So to create a vector which contain days from 1 to 365, that means it contain day 1, day 2, day 3, day 4, and so on, goes up to 365. So we have 1, 2, 3, and so on, it goes up to 365. So you see there is a gap of 1 in between these numbers. So 1 to 2, there is a gap of 1. 2 to 3, there is a gap of 1. So by default we can use the colon operator to create this vector between points 1 and 365. Let's create a vector d which contain element from 1 to 365. So I can use this colon operator to create a vector between 1 and 365. If I press an enter key, a vector d will be created which contains the elements from 1 to 365, and it contains the element up to 365, and the column are also up to 365. Another way to create the same vector is using linspace command, because we know the first point, which is 1, we know the last point, which is 365, and we know how many days are there in year. So there is 365 days. So I can use this linspace command, which will create the same vector we created using the colon operator. See, the same vector is created. It contains again 365 columns and elements up to 365. Next one, we have this create a matrix A, which is 9th problem. So create a matrix A of size 5 cross 5, which contains first 25 prime numbers. Also find A square transpose inverse of it eigenvalue, then determinant, then we have to multiply it with some matrix B of our own choice, and for that we have given hint which says magic, either use magic command or there is some special command to create random numbers between 0 and 1, which is rand function, and which takes in number of rows and number of columns as an input. Let's create a matrix A. So for matrix I am using this capital alphabet, then I will use the square brackets, and then I will start writing my prime numbers in between these brackets. So these are the first 25 prime numbers, and we have created a matrix A which contains 5 rows and 5 columns. That means total of 25 elements is there. Now we have to do different operations, such as we have to find out A square, then we have to find out transpose of matrix A, then we have to find out inverse, eigenvalue, determinant, and then we have to multiply matrix with B. So let's first find out A square. So to find out A square, we can either do this A into A, or we can also use this raise power operator, this special operator. Using shift plus 6 button you can access it, and then I will use A square by writing this A2. So I will press an enter key and A square will get evaluated, and this is my result, which again contains 5 rows and 5 columns. Next we have to find out transpose of A, which basically means to change the rows into columns and columns into rows. So I use this transpose A, then this 2 3 5 7 is now in the vertical direction. Initially if I press A and press an enter key, you see this 2 3 5 7 11 is now in the horizontal direction, and now after taking transpose of A, they are in the vertical direction now. So they just change from rows to the columns. Next we have to find out inverse of it. So to find out inverse, we will use this inverse command inv, and then I will supply this matrix A. If I press an enter key, I will get the inverse of matrix A. Next, if you are familiar with the eigenvalues, so if we have a square matrix A or any matrix, then I can find out the eigenvalue of that matrix. So to do that into MATLAB, we can call this command known as EIZ, and then I will supply this matrix A. So this will help me to calculate the eigenvalue of matrix A. If I press an enter key, it will give me these eigenvalues 2.2998, and then you will notice there is some extra sum there, so it is plus 0.000i. So this I basically means it is a complex number. Okay, so this is not a real number. Along with the real number, it is having some imaginary number, so that means this 2.998 plus 0.00i is a complex number. A matrix can have eigenvalue real values as well as the complex values, so that's why it's showing some of the values in terms of complex numbers. Next we have to calculate determinant. So to find out determinant, we can use this det command, and then I will supply the matrix A. It will give me the determinant of matrix A is minus 4656. So minus 4656 is the determinant of this matrix A we created, which contains first 25 prime numbers. Next we have to create matrix B. To create matrix B, we can use this magic command, and I will supply how many number of rows I want or columns I want. Basically this magic matrix will create a square matrix, so I will supply only one number. That will give me the matrix B, which contains these 5 rows and 5 columns. Now I will multiply matrix A with the matrix B. So to multiply, we have to make sure that number of columns in matrix A is equals to number of rows in matrix B. So let's find out the size of A first. So size of A is 5 rows and 5 columns. So this one indicates rows and this one indicates number of columns. It contains 5 columns. So now check the size of B matrix, and the matrix of B contains 5 rows and 5 columns. So this number of columns in A matches with the number of rows in B. Then we can also create matrix B using this command, which create random floating points between 0 and 1. So I will supply number of rows I want. So let's suppose I want 5 rows and 4 columns. So this rand command is used to create a random number between 0 and 1. It will give me a matrix B which contains 5 rows and 4 columns. If I press an enter key, you will see all those numbers that are generated are random and they are having the value between 0 and 1. So if now I multiply matrix A with matrix B, I get this matrix which is stored in the default variable answer. This is my matrix, which is the multiplication of matrix A and matrix B. I can also do element wise multiplication. To do the element wise multiplication, we have to use this dot symbol in front of multiplication. So I will supply multiplication and then I will write B, and then if I press an enter key, it gives that arrays have incompatible size for these operations. Because if you check the size of A, it is 5 rows 5 columns, but if you check size of B, it has 5 rows but 4 columns. So for element wise multiplication, matrix dimension should be same. So size of A must be equal to size of B, then only we can do this element wise multiplication over here. So to make the matrix of same size, so I will create some basic matrix for B. My mistake. So B is equal to magic, and then I will supply how many columns I want or rows I want. So it will give me a square matrix B. Now I can perform the element wise multiplication. It will give me this matrix answer, which contains 5 rows and 5 columns. So element wise multiplication can only be done with the same size matrices. So A and B should have same size matrix, should be same size matrix. Next we have this 10th problem, which says we have to do this different operation like use size function, endtimes function, numeral function, length function commands on B matrix, and then we have something called disp command. So let's see this one by one. So we have already seen this size, which actually tells the size of matrix, any matrix. So it says 5 rows and 5 columns. Next we have endtimes. So endtimes command is used to find out the dimension of matrix. Matrix B contains rows and columns, so it's basically 2-dimensional matrix, so it should give me 2. Next we have this command numeral, which basically give the number of element in B. So if you say here 5 rows and 5 columns, so it's 5 into 5 means 25 elements. So if I supply B, so it should give me 25. So this numeral command is used to find out number of element in matrix. Endtimes is used to know the dimension of matrix, and this size command is used to know the number of rows and columns in a matrix. Then we have this command known as length command. So this length command is basically used to find out the length of vector. So instead of operating on matrix B, it is helpful to operate on vectors. So let's first operate on matrix B. So this length command on matrix B will give the maximum value, so which is basically 5 here. So to know the actual use of this length command, I will operate it on some vector. So let's call it on some vector length of t. T is my vector which contains 201 columns and 1 row. So it will give me this answer 201. So this length of t is basically helpful to know the size of a vector. So let's access all the functions available for the matrices using help elmat. If I press an enter key, this will give me all the functions that are available to operate on the matrices. So these are the element matrix and matrix multiplication functions. And if you see here, this length command is length of vector. If I click on it, it will give me this help for length, which is length of vector. So length of x, return the length of vector x. It is equivalent to the max. This max command is to find out the maximum number in the any matrix or any vector we supply into it for non-empty array. So max means it will find out the maximum of this size of x, whatever size of x is used for to find out the rows and columns. So it says let's create a matrix D, and let's create a matrix with ones which contain all the elements 1, order 5, rows 4. So if I created this, if I call size of D, it will give me number of rows is 5 and number of columns is 4. Now if I call length on this matrix D, it should give me 5, because in between 5 and 4, 5 is maximum, so it will give me the maximum value of the size. So if I call max, then if I call size of D, then it will give me 5. So this length basically equivalent to this command, maximum of size. So this max command is helpful to find the maximum value in any vector or matrix. Next one, we have this disp command. To understand the disp command, let's create a vector C which contains some natural number like 1, 2, 3, 4. Then I will move to the 5, 6 next row, 5, 6, 7, 8. So to understand the disk command, what I'm going to do is I'm going to use a semicolon after this command. So this will create a variable C. This is assign operator, and this is my list of numbers, or it will basically give me a matrix. So 1 2 3 4, then 5 6 7 8. If I press an enter key, you will see no result is displayed after I pressed an enter key. If I do not use this semicolon, you will see the result is displayed as soon as I press an enter key into the command window. But if I use this semicolon, no result is displayed. So this semicolon over here within the bracket means we want to move to the next row, and this semicolon outside of the bracket means to prevent displaying of the result into the command window. So this is helpful when we will be writing script into the script files, and we do not want to show each and every result into the command window. So we will use this semicolon after any variable or matrix we create. And now to display this into the command window, we will use this command disp, which is short form of the display. So I will use this disp command, and if you wait for 2 to 3 seconds, then this help will displayed here, and it says supply some variable x. So I will supply C into it, and if I press an enter key now, you will see the element that is contained within this variable C is displayed. Okay, so one more thing, if I use disp and then I use this C, and then if I use the semicolon, it will still display the result. So this command is basically used to display the result into the command window. Even though if I use the semicolon after this, it will not affect the result shown by this disp command. But if I create, let's suppose I create a variable C, or let's name it some f, and let's store a value in it, and if I press semicolon after it, that means I don't want to display it into the command window. If I press an enter key, it will not display the result. But if I use this command and then I supply f into it and I use semicolon now, it will still display the result. So this command is used to display the result into the command window. So this will be helpful when we will be writing script commands, and if we want to show some of the result into the command window, then we can use this disp command. Next and the last problem is the 11th problem, in which I want to write this text into the command window. Along with that, I want to store this numeric variable into this text command as well. So let's write this command. So to write the text command into the command window or in the script files, I have to use this double quotes. So I will use these double quotes, and whatever text I want, I will supply this text within these double quotes. So my name is Sam. Let's write first this. Now my name is Sam. If I press an enter key, the result will be displayed here. My name is Sam. Now I will complete the sentence. So to do that, let's create a variable name as age and store a value in it 40. Okay, so by naming the variable as age, it is just helpful to distinguish different variables. So if I have to see in the workspace and I want to know the variable age in it, it will be clearly visible if I have specified the name in this way. So that means it is indicating age. So if I press an enter key, a variable is created with the name age. You can name it any variable you want. Now if I write my name is Sam, then I will close this double quote, then I will press plus, because I have to now add this numeric value with the string value. So I will use this plus, then I will use again plus, then I will use this double quote and complete the sentence. Okay, so my name is Sam and I am, then age will come, and then we have to supply is 40-year-old. If I press an enter key, now the text is appeared in the command window. So my name is Sam and I am 40-year-old. But one thing you will notice, there is no gap between am and 40 and year. So there is no space between this. So let's try to give space. If you try to give the space outside of this double quote, let's see what happens. So I have given space in between these plus symbols age, and I separated these text files by using again space. If I press an enter key, still there is no space. What happens actually? So this is because we have to provide the space within double quotes. So if I provide space here and a space here as well as, and if now I press an enter key, you will see now a space appeared in between M and 40 and 40 and year as well. So if you want to give space in between these texts, you have to supply the space within these double quotes. Another way to do the same thing is using plus symbol. Then I can use double quotes, and here I will press a space. Okay, if I press an enter key, you will see a space is now available in between this M and 40, because with the help of this I have provided a space. So you can do either this way, or you can also provide the space within this text over here. So this was all about today's tutorial, and we covered these 11 practice problems, and we try to implement all those skills we have learned till now with the help of those 8 tutorials available in the playlist in the introduction to MATLAB. I hope you like this tutorial. Please like, share and subscribe. I will see you in the next tutorial. Thank you very much.